Integrals are just working backwards. So if you remember what a derivative is of something, and you recognize that derivative, so if you know a derivative of something, an integral is just working backwards, and if you recognize it, then you can undo it. So we mainly have worked so far with power law, which working backwards would be adding 1 to the exponent, but we realized that a good strategy then is now, if you divide by that number, that undoes the multiplying by that number. We saw number 2 already because I showed it to you and tricked you so that you got it wrong. The 1 over x is hard to read. It's easy to remember the derivative of ln x was 1 over x, but working backwards, the 1 over x is going to tempt you to think of a power and go the wrong way. So when you see a 1 over x, working backwards, that would have been the natural log of x. And then, of course, I could have just done e to the x, and the derivative of e to the x is e to the x. So working backwards, it would also stay the same. But if you had a little chain rule in e, this makes sense. If I had a chain rule in e to the x, so for example, if you were finding the derivative of this, your derivative would be the same thing, but then because of the chain rule, you would multiply by 3. So if you were undoing something, if you were working backwards, if you had that the derivative was e to the 3x, and you wanted to find the original, you would have to divide by 3, because when you do the derivative, you would multiply by 3. So the idea is you just get really good at derivatives, then you start to work backwards, and it messes up with your brain. So for this one, I would probably use the rule that you can always bring a constant out in front of an integral. So that 12 you could bring out in front. This lets you see really easily that you have a natural log. So try the next 2 on your own. How did you do? And with an integral, since integrals are going to be more difficult than derivatives, whenever you get an answer to an integral, you can always take the derivative of it to check. And in this case, if I took the derivative of this, I would have a chain rule. The e to the 5x would stay the same, but then I would multiply by 5. That 5 that I multiply by simplifies with the 10. And I get the 2 on the bottom, so it works out. And of course, if you wanted to, now you could simplify this one. Multiply by the reciprocal. Almost. Wait for it. Okay, so now you have to apologize to your brains, because what we're about to do is about to mess them up again. We've got our derivatives of sine and cos. And then our integrals of sine and cos. So do you remember that the derivative of sine was positive cos, and the derivative of cos was negative sine? But now that we're going backwards, that means the integral of sine is negative cos, and the integral of cos will just be sine. And your positive and negatives is just going to cause your brain to go, oh my goodness. So I will remind you of what we did to remember this with our derivatives. And hopefully that makes you connect with the integrals. So a little reminder that I said, if you think of the graphs, here's the graph of sine. The first tangent on the graph of sine is positive, so the derivative of sine is positive cos. If we take the graph of cosine, and we look at where the first tangents go on cosine, they go negative right away as far as their slopes. The derivative of cos is negative sine. So now when you're working backwards, since sine to cos was positive, positive, going backwards, cos to sine stays positive. Because going from cos to sine changed from positive to negative, now going backwards on sine, you've got to go negative to cos. But if you just try to memorize this without connecting it somehow to a reasoning how you memorize it, you're going to mess this up very easily. And same thing here. I could have just done regular sine and regular cos, but if you have a simple chain rule, which causes you to multiply, that simple chain rule can be undone by dividing. Positive or negative? Negative. Whew. Add 1 to the exponent, divide. Integral of e to the x would be e to the x. And positive or negative? It was originally negative. Does it change to positive, or does it stay negative? Steady state. Wait for it. Oh, there we go. So this idea that I did in e to the x and sine to the x with a simple chain rule, the simple chain rule can be extended to look like this. If you have a chain rule where the inside function is a line, in other words, mx plus b or ax plus b, whatever way you want to talk about it, right? If we think about our simple derivatives, okay, and we want to find the derivative of each of these, we would notice the following, right? It's a chain rule, so my derivative would be, right, the 7 would come out in front, keep the inside the same, and then the derivative of the inside would just be 5. So if I had ax plus b cubed, the 3 would come out in front, the inside would stay the same, subtract 1 from the exponent, and the derivative of the inside would just be whatever's in front of the x. This is true for the power rule. Notice it's going to be true for your natural law. Here we have a chain rule with a line, 4x plus 7, inside of the natural law. Its derivative would be 1 over, keep the inside the same, multiplied by the derivative of the inside times 4. So if we had any line inside, we would keep the inside the same, multiplied by the derivative of the inside. And same thing with e to the x. If I had e to the x, its derivative would be derivative of the outside, which is the e to the x function that keeps everything the same, multiplied by the derivative of the inside function. If you had any line, your outside function of e to the x just keeps everything the same. Then you would multiply by the derivative of the inside function. What this is telling us, since we're just multiplying by a number and not a variable, we can undo any integral of this form by doing the opposite of multiplying, which would be divide. But I think I have even more sine. Let's do sine and cos. Derivative of sine, positive or negative? I'll leave the space out in front. You can tell me afterwards. Should it be positive or should it be negative? Positive. It's going to hurt the brain, right? So again, this is where I always go back. This is the picture. I always think just in my derivative form. I'm going from sine to cos. I think of that picture. It's going to be positive for the derivative. Otherwise, it's just going to be a mess. Try that. And anyone then, this will be positive cos, keep the inside the same, multiply by the derivative of the inside. And for cos, here we'll have the negative. So if your inside function is ax plus b, any line, the chain rule will have just multiplying by a number. This is powerful because if we notice that with all of our derivatives, then we can do all of our integrals that have an ax plus b in them by just adding a dividing by a to undo that chain rule of multiplying by a. First of all, I'll change this to a 1/3. Write it in integral form there. So, regular power rule would say integrating, I'll add 1 to my exponent and divide, but I also now have to divide by 5 because of the chain rule. Plus c, so this will equal multiply by the reciprocal. So generally, in these ones, you would still need to simplify that last step because it's still you're not happy if you have fractions inside of fractions. So the bottom has a fraction inside of another fraction, multiplied by the reciprocal to get our answer is a single fraction in the end. That is still expected. I would change this. And then add 1 to my exponent and divide by my exponent. And also divide by the 9 because of the chain rule. I hope some of you are thinking, what if it's a chain rule and it's not a line? Can we still do this? No. And it gets absolutely messy. Lines are okay. After that, it gets messy. Like, what I mean is, if we had this same question like this, but I had 9x squared. The question is, could I do this? Add 1, divide, and derivative of the inside would be, not just a 9 now, it would be 18x. Can I just divide by 18x? Absolutely not. It does not work, not even one little bit. The reason it doesn't work, not even one little bit, oh, I know you were waiting for it, there it is. Okay. The reason it doesn't work, not even one little bit, because if you did the derivative of this to check, you would have to use your quotient rule, because you have an x on the bottom. And your quotient rule, you know what that looks like. It's like keep the bottom the same, derivative of the top, minus keep the top the same, derivative of the bottom over the bottom squared will give you a whole bunch of x's and not even come close to matching up with this originally. This is going to be messy. So if you had your natural log and it was a nice line inside, you could do that by dividing out the chain rule. Or if you have an e to the x and it was a nice line inside, just ax plus b inside, then you could just divide to get rid of your chain rule. The hard part will be, I think the natural log is the hardest one to see. This is the same as I'm going to pull the 15 out, because you're allowed to pull out a constant. And you have a 1 over x with extra stuff on the bottom. So this is a natural log with a chain rule with a line inside of it. Oops, brain was thinking ahead. Just simple, I brought the 15 out front, the integral sign would be there. Now, this integral would be the natural log of 3x minus 5, and because of that chain rule, we would have to divide by 3. Natural log 1, though, is the hardest to recognize. So whenever you have 1 over something, and the something that is over is just any line, then you have a natural log. But if you had 1 over x squared, then you could change it to x to the minus 2, and you would have a power rule. So it's only when it's 1 over a line that you'll have your natural log. We have an e to the x. Inside is just a line. So integral will be exactly the same, but chain rule would say we'd also have to divide by that -3. Does it matter that there's a 3/7 as a fraction? No. It's just there to make you look more impressive when you do your derivatives or integrals. Same thing with sine and cos. If you have a line inside, you have to divide out that chain rule. You know what I did one time for my notes? I printed them all off, and I accidentally made the mistake of switching the negatives in the wrong places with sine and cos. Are these ones right? Are they? Yes. But can you imagine after I say, first of all, how hard it is to remember those two and they're easy to mix up? And then I printed off my entire notes with them wrong? That's funny, but not nice. So we want to find the indefinite integral, so we write it out with no. I was so proud that I didn't screw up the negative sign. I should say minus. Yeah, I was supposed to do minus. I was going to make up some stupid rule that, oh, it changes to a plus when the number in front of x is a multiple of the number in front. That's a special rule you have to memorize. No. Stay negative or go positive? How are we doing?